Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 10.1, Problem 2. This is Section 10.1, Problem 2. It says, consider the function f of x equals 3x squared minus 2x plus 5, and find the following. And there are 6 parts, A, B, C, D, and F. So part A says find f of 4. So what I'll do for part A is take the function f of x equals 3x squared minus 2x plus 5. And what this is basically telling me is everywhere I have an x, put in a 4. That's what f of 4 means. So f of 4 equals 3 times x squared becomes 3 times 4 squared, minus 2 times x becomes 2 times 4, and then you have plus 5 at the end. So 4 squared means 4 times 4, which is 16, times the 3 in front. 3 times 16 is 48. Then minus 2 times 4 is minus 8. Then you just have a plus 5 at the end. So 48 minus 8 is 40, plus 5 more. The answer is 45 for part A. F of 4 is 45. And that means if for that function, if you put in a 4 as an input, the output you get is 45. Part B says find f of 1, which means put in a 1 as an input and see what you get out, or replace every x with a 1. So it's going to be the same type of process. Start with the function that's given, f of x equals 3x squared minus 2x plus 5. And because the problem says find f of 1, for the function that's given, wherever there's an x, replace it with a 1. So f of 1 equals 3 times x squared becomes 3 times 1 squared, minus 2 times x is 2 times 1. There's a plus 5 on the end. 1 squared is 1 times the 3 in front. 3 times 1 is 3. Minus 2 times 1, so you have minus 2, plus 5. So 3 minus 2 is positive 1, plus 5 more is 6. So f of 1 is 6. If you put in a 1, you get out a 6. Part C, find f of negative 6. Now, because of the negative, take your time a little bit more. Be careful. Negatives are very easy to make a careless mistake on. So, again, the given function for this problem is f of x equals 3x squared minus 2x plus 5. And because the part of the problem says find f of negative 6, wherever there's an x in the question, replace it with a negative 6. And watch your signs. So that's going to give us f of negative 6 equals the 3x squared will become 3 times negative 6 squared. Then minus 2 times x is minus 2 times negative 6. And then you have a plus 5 on the end. Now, here's where we have to be careful. 3 times negative 6 squared. Let me write out an additional step for this one. Negative 6 squared is negative 6 times negative 6, which is positive 36. Right? The negatives will cancel. And then the next part of the problem, negative 2 times negative 6 is positive 12. Again, the negatives cancel, and there's a plus 5 on the end. So 3 times 36 is 108. And then plus 12 more, plus 5 more after that. So 108 plus 12 is 120, and then 120 plus 5 more is 125. So if you put in a negative 6, you get out a positive 125. Now, part D, also a little bit odd, not a negative, but f of 1.4, the decimal. Well, you can do that. Just replace every x with that decimal. So, part D, find f of 1.4. Take the original function, f of x equals 3x squared minus 2x plus 5. And wherever you have an x, replace it with the input value. In this case, 1.4. So f of 1.4 is 3 times x squared is 3 times 1.4 squared. Minus 2 times x is 2 times 1.4. And then plus 5 on the end. So, again, let me take my time a little bit here. 3 times 1.4 squared is 1.4 times 1.4, which is 1.96. Then 2 times 1.4 is 2.8, but be careful for the signs. It's negative 2 times positive 1.4, so it's minus 2.8. Then you have plus 5 on the end. So 3 times 1.96 is 5.88, I think. Let me just check that with my calculator. 3 times 1.96 is 5.88. Minus 2.8 plus 5. So 5.88 minus 2.8 is 3.08 plus 5. 3.08 plus 5 is 8.08. So f of 1.4 is 8.08. For this function that's given in the problem, if you put in a 1.4, you will get out an 8.08. Now the next part, part E, f of 1/2. So now we have a fraction. Nobody likes fractions. But it's not too bad. Just follow the process like we did when it was positive whole numbers. So the given function for this problem is f of x equals 3x squared minus 2x plus 5. And it tells you use an input of 1/2. So wherever you have an x, replace it with a 1/2. So f of x becomes f of 1/2. 3 times x squared becomes 3 times 1/2 squared. Minus 2 times x becomes minus 2 times 1/2. And then you have a plus 5 on the end. Now you might be thinking, oh, 1/2 squared, how am I going to do that? Well, 1/2 squared is 1/2 times 1/2. So let me write that off to the side. 1/2 second power is 1/2 times 1/2. So when you have fractions, top times top, 1 times 1 is 1, bottom times bottom, 2 times 2 is 4. So 1/2 to the second power is just 1/4. That's not too bad. So we have 3 times 1/2 squared becomes 3 times 1/4. And the 2 times 1/2 is nice. The 2's cancel. The 2 times the 2 in the denominator cancel. So 2 times 1/2 is 1, but it's negative 1 because it's minus 2 times positive 1/2. And you have a plus 5. So 3 times 1/4 is 3/4, right? If you have a quarter and you have 3 of them, it's 3/4. And the negative 1 and the positive 5, I can combine those. It's going to be positive 4. So you have 3/4 plus 4 more is 4 3/4. Or if you like decimals, 4.75. But anyway, if you put in a 1/2, you will get out a 4 3/4. A positive 4 3/4. Now, part F. F of h plus 2. So we're using a different variable as an input, which again seems weird, but follow the same process. So the given function in this problem is f of x equals 3x squared minus 2x plus 5. So the problem is basically telling you, when it says find f of h plus 2, put in an h plus 2 as an input, or in other words, wherever you see an x, replace it with h plus 2, whatever the input is. So f of x becomes f of h plus 2. 3 times x squared becomes 3 times h plus 2 squared. Minus 2 times x is minus 2 times h plus 2. Then you have a plus 5 at the end. So that is the answer, but you have to simplify the algebra. You can't just leave it like that. So the rest is just algebra. Now, h plus 2 squared, be careful with that. It's not just h squared plus 2 squared. That's in there, but there's some other stuff in the middle. So again, let me just go up above a little bit. Let me do it in a little bit of a different color. So h plus 2 second power, h plus 2 squared as we'd call it, is h plus 2 times h plus 2. And we have to do that, remember, FOIL. So the h times h is h to the second. The h times 2 is plus 2h. Then the next 2 times the other h is another 2h. And then 2 times 2 is 4. And the 2h and 2h can be combined. So I have h squared plus 4h plus 4. The 2h and 2h combined to make a 4h. So let me come back down to the problem I had here. 3 times h plus 2 squared. So now I'm going to have f of h plus 2 equals 3 times the result of the h plus 2 in parentheses to the second power I'd written up above is h to the second power plus 4h plus 4. And now the 2 times h plus 2, I can clear the parentheses. Keep an eye on the sign. Negative 2 times h is minus 2h. Negative 2 times positive 2 is minus 4. And then you have a plus 5 at the end. So we're still not done. I have a 3 in front of another big set of parentheses that I can clear. So f of h plus 2 equals, so I have a 3 times h squared is 3h squared. And then I have a 3 times 4h will be 12h. Then 3 times 4 is 12. Then from the rest of the function, I have minus 2h minus 4 plus 5. Now I can combine my like terms. So f of h plus 2 equals, so I have a 3h squared in the beginning. And as I look through all the other terms, there are no others with an h squared. So I have 3h squared, and that's done, so I'll cross it off. Now, terms with an h, I have a positive 12h and a negative 2h showing up in 2 different parts of the problem. Well, I can combine those because they both have an h. Positive 12, negative 2 is going to be positive 10h. So the 12h and the negative 2h are done. And then just numbers with no variables, or what the math book would call constants. Positive 12, negative 4, positive 5. So I can combine those. So 12 and 5 is a 17. Combine that with a negative 4, and you'll get positive 13. And now that's as far as it can be simplified. So if you find f of h plus 2, or in other words, put in h plus 2 as an input, the output that you will get is 3h squared plus 10h plus 13.